This is a video all about the tangent ratio, which is one of our three trig ratios. So a trig ratio is a special relationship between the sides of right triangles. So if you have similar right triangles, so that means all the angles are the same, but they're just larger or smaller, the ratios, between those two different sized triangles, that's called the scale factor. You've learned about this. Like, that's the same from side to side. Corresponding sides between the triangles. But turns out, if you have similar triangles, these ratios of just on one triangle itself is the same between different size triangles. So for example, we're learning about the tangent ratio, which is the length of the opposite side to an angle over the length of the leg adjacent to an angle, which is right here. And no matter what size of right triangle you have, as long as it's similar, all the angles are the same, that ratio will be the same. So the tangent ratio, so that's written as TAN in your calculator, that's what that means. So tangent of A equals the opposite side to A, which if this is your angle A right here, the opposite side is the side that doesn't touch it, over the adjacent side, which is the leg that does touch it. So this tangent ratio doesn't have anything to do with the hypotenuse. And you can use this to find angle measures or to find missing side lengths in just a single right triangle. And remember, this only works for right triangles. So let's do this first example here. So find tangent of S and tangent of R. Let's do S first. So angle S is up at that top right corner, and tangent of S equals the side opposite of S, which is the leg that doesn't touch S, which is 80. Actually, here, I'll write the opposite side. Opposite of S over the adjacent side to S. So the opposite side is 80. And the adjacent side is the leg that touches angle S, which is 18. And that's the trig ratio. So tangent of S equals 80 over 18, which you can simplify to divide each side by 2, so 40 over 9. And that's tangent of S. So now tangent of R, again, is the opposite side over the hypotenuse. Here, let me erase this. But it's not opposite to S anymore. Now we're looking at R as our reference angle. Whoops. Okay. So R is our reference angle. The side opposite to R is the leg that doesn't touch it, which is 18. And the leg adjacent to R is that leg with measure 80. So that means tangent of R is 18 over 80, which is 9 over 40. You might notice that these two answers are reciprocals of each other. So you have 40 over 9 for tangent of S and 9 over 40 for tangent of R. That's always going to be true. Just a little pattern recognition thing. Okay, let's keep going. Oh. Alrighty. Okay, now we can use tangent to find a missing length in a triangle. And this is where you'll need to learn how to use a calculator, which is on the next page in this module. It's really important. You can use your phone. If you have an iPhone, you have to turn it sideways to get all of the functions. You can use like a physical calculator like mine, or you can use Google Calculator. If you need help using your calculator, let me know, and I'll help you out. Okay, so let's set up this ratio and then solve for it. Okay. So we only know tangent so far, so we're going to use tangent. But you would know to use tangent because we know this angle here and we know this opposite side, and we know this, or we don't know this adjacent side. That's what we're trying to find. So tangent of this angle, which is 32, so we can just say tangent of 32. This is where your calculator comes in, because turns out this tangent, it's a ratio, but it's also a function, and your calculator knows this function, so we don't have to use tables or anything like what you saw in the last module. We can just use our technology. It's programmed into our calculators. Pretty nice. Okay, so tangent of 32 equals that opposite side, which is 11, over the side we don't know, x, the adjacent side. So opposite over adjacent, 11 over x. Now, let's see. So to solve for x, what's the easiest way to do this? So multiply both sides by x, and then divide both sides by tangent of 32 to get x equals 11 divided by tangent of 32. And I should be writing degrees here. Degrees. And now it's a calculator game. So I type in my calculator, 11 divided by, I find the tan button, tangent of 32. And you get 17.6. And then you check, is that reasonable? Yeah, it's a little bit bigger than 11. Could be reasonable. All right, and that's what x equals. Next example, same process, same idea. So this is our reference angle, 56. So tangent of 56 equals the opposite side. So the leg that doesn't touch this 56, which is x, over the adjacent side, which is the leg that touches that angle, so it's 13. To get x by itself, multiply both sides by 13 to get 13 times the tangent of 56 equals x. It's 56 degrees. So now, use your calculator, type 13 times tangent of 56, so tan 56, to get 19.27 equal to x. All right, and that's how you use tangent to find the missing leg lengths in a triangle. So notice in these triangles, we didn't even need to know what the hypotenuse was at all. But now that we know the other leg, we can use Pythagorean theorem to find the hypotenuse if we wanted to. All right, let's move on. I have one last example for you. And these are the classic tree problems. Remember when we used proportions to solve this? You had to use your shadow, so your height and your shadow, compare that to the tree shadow. Turns out if you just know that angle and the distance you are away from the tree, then you can find the height of the tree. There's this thing called a clinometer that is like a physical object that you can measure angles, which, if you had one of those, there's an app you can get, so it's possible to do, to find the angle of elevation, which is, if you're looking straight at a tree, the angle of elevation is the angle it takes for you to look from like the base of the tree to the very top of the tree. That's the angle of elevation. Okay, so you're measuring the height of a spruce tree. We're 45 feet away from the base. The angle of elevation from the ground to the top of the tree is 59 degrees. Find the height of the tree to the nearest foot. So we know this is a reference angle. We're looking for the opposite side. And we know the adjacent side, so we're going to use tangent. So tangent of this reference angle, which is 59 degrees, equals the opposite side, which is h, we don't know it, over the adjacent side, 45 feet. Multiply both sides by 45 to get 45 times the tangent of 59 degrees equals the height. And then use your calculator. So 45 tan of 59 to get 74.9, so almost 75 feet is the height of this tree. Pretty cool, no? Okay, that's it for the tangent ratio. Watch the next videos to find more about cosine and sine ratios. And email me with any questions that you run into, all right?